All right, I'm continuing this series here, and this is that symbol that I was talking about in my last video. It's a symbol that was used in, you would find in illustrations during the Renaissance era, and it, I have been working with this symbol, and I know there's a few variations of this symbol, but this one in particular is the one that I've been trying to work with. And yeah, I mean, as far as like I've come to kind of understand, is that it's a foundational symbol of geometry. And I wonder why they would put that together like that. Like for reasons of geometry, right? Not regarding other kind of subject matters. But I think there must have been a reason. And so I'm going to share with what little I have found so far. And before I get into the actual presentation here, I did want to address something. Excuse me. Somebody left actually a very good comment on my last video regarding accuracy. And there are things that, first of all, there are things that affect your accuracy. And one of them is the actual drawing compass itself. And you can see here, that has a very dull tip on this one, so it might have a tendency to slide around. And the other one is that they might have a tendency for a little bit of play and a little bit of movement on there as you are using the instrument. And I mean, for what it's worth, I actually got this from a dollar store, I believe. It's very convenient. It's very handy. So that's one factor. And you can use a more of a precision drawing compass. Now, it's not going to give you incredible accuracy in terms of the third or the fourth, decimal place. But nonetheless, these ones come with a very sharp tip, and they will certainly not going to move around as much. And secondly, there is no play on here. Like, this will not open and close as you are using the drawing compass. And this one I picked up, believe it or not, I found it at a thrift store many years ago. Made in Germany a long time ago. I don't even think the company's around anymore, but it's a beautiful work of machinery. It's a beautiful tool, and I'm fortunate to have found this. So that's another a factor of accuracy. The other one is when you are using a straight edge ruler. Sometimes the straight edge is not as flat as compared to other straight edges. Like I have a wooden one which is pretty good. I've used other plastic ones before, and I have found that there are these slight little dips and stuff like that in the ruler, and I wasn't, it wasn't good enough for me. It can be good enough for rough projects, but so you got to keep that in mind. Like, not all straight edge, rulers have the same degree of flatness in terms of that accuracy of flatness, and so that's another thing that can affect your accuracy. And the other one is the actual thickness. I don't think that's going to focus on there. The actual thickness of the lead. Like this is thin, and this one on here is a lot thicker there, as you can see. Mind you, they used to sell these little sharpeners for these types of leads. They probably still do, and but anyway, so that's another kind of point that will affect the accuracy, is the actual thickness of the of your pencil, or be it another you know instrument of your drawing. So that can also affect the accuracy. I mean, to a reasonable degree, the thicker your kind of lines are, of your pencils or whatever else you're using, the more kind of leeway that you have, and the finer your lead is, for example, the 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 more accuracy, but then again, the less leeway that you have. And so, anyways, I just thought I'd share what I have come to learn. Um, I've been doing this for less than 7 years. I can't exactly remember when. It could be 5 years. It could be maybe something closer to 6 years or something. That I've actually just spent hundreds and hundreds of hours just with geometry, and trying to learn on the go and experimenting with stuff. And so, regarding stuff in comparison to today's accuracy, where they have precision instruments, digital angle finders and digital calipers, and high precision instruments, they are certainly very valuable, and are used for like specific types of jobs, and specific types of vocations, and specific types of manufacturing, like a high-end machinist, for example. They will have the most precise as possible instruments and tools and machines that one needs, because the stuff that they make and manufacture needs to have a precision level of at least a fourth to a fifth kind of a decimal place, literally to the 1,000th of a whatever, in some cases. So this is just old school geometry, and I'm intrigued just to how things were done, several centuries ago, with just kind of the most basic of tools that they had. And the other thing is if the main kind of purpose also is with like a drawing compass, for example, if you can get to within a degree or less, is optimal, because then you can always fine tune something, right? You can always fine tune your instrument, and if you can get to like better than just like the right ballpark kind of thing, that's a great start. That saves you from having to play more of a guessing game, and you keep trying and trying and trying and trying. You open your thing up a little more, open your thing up a little more, or close it a bit, close it a bit, close it a bit, until you get something, that gives you a greater degree of accuracy. But to get something within the right ballpark, and to a certain level of accuracy, there is is essentially optimal. And yeah, that's my kind of thoughts on accuracy and drawing compasses, and I'm trying to learn and rediscover possibly some of these types of techniques and this kind of knowledge that they might have, or rather that they would have had, um, a few centuries ago. After all, they were very capable people during the Renaissance age, and had created and designed and created incredible works of architecture. Um, you know, to the point where lots of people are still kind of puzzled by that today. It was like, oh my God, how did they do this? How did they do this? How did they do this? Well, the first step of how did they do it you actually have to learn, or rather relearn, these older methods, as to answering the question of how they did it. And um, and oh, I've drawn a blank here. I forgot what else I was going to say. Yeah, that's the first step. The first step is to actually try to relearn some of this stuff. I mean, I don't know. Is there some like rare copy of a geometry book from, the 1700s that I don't know about, or something like this, where they shared all this information? As far as I know, I'm unaware of it. So I have been in the process of trying to just simply rediscover some stuff here, and whatever I can find, I share. I just put that out there. It's a very small niche of interest, considering all the things that are available to people, and everything that that modern um, the modern age can provide you. But then again, maybe there's a rare kind of person like me who just happens to be interested in this stuff. So that's that. Okay, let me continue here, and I will share what I found here. This will be, to start here, this will be easier for me to start with this very symbol here. That little measurement there between the tip of the triangle and the top of the square, I found that when you go to your horizontal axes and make that mark there, approximately there, and then connect a line from one of the corners of the triangle to that point, I found this to be a very close, okay, I'm not going to say precise, but a very close angle of 7 into 360 of approximately a 51.42. And if somebody has the type of computer software that can figure out all these angles or other kinds of precision instruments, that's wonderful, because that kind of information actually helps me. Like, how far off am I in terms of like precision down to the decimal points? Like, I doubt that this is going to be exactly 51.42857114. You know what I mean? I doubt it, but if you can get to like within a degree or less, I think even a degree is quite substantial. A 0.5 of a degree or less, I think that's really good, because you can fine tune your drawing compass after. It gives you a great place to start. But this is the first thing I found on here, using this very symbol that we found, that we can find from the the classical or the Renaissance period, for example, was I found this one first. I was curious to know what this what might possibly lead to. And when I placed it from here and marked it to there, I found that line gave me a very reasonable measurement to getting a heptagon and or a septagon using a drawing compass. Okay, so that's that. So that's the first one I found, which I've kind of marked here. Of course, these are going to be what's that measurement there, to this measurement there, and that line there I found to be a very reasonable angle, and I used it to complete this seven-sided polygon here, because that gives you this measurement with your drawing compass, like this. And then you can just go around and scribe those points. And you see, if that's off a little bit, like literally a hairline, okay, that level of accuracy is easily compensated for with your compass. You mark around and until you come back to your starting point, and that'll tell you, are you short or are you long? And usually, like, just a hairline fracture will end up throwing that off, right, to the point where you'll be out like this much, or you'll be under that much. But like I said, it's a great place to start. At least you have something to work with where you don't have to do this like 50 times. You can just do this in literally like 2 or 3 passes, and you fine-tune it, and you have it. So that's the other thing with these kinds of older methods. And so once again, I've directly used this symbol here as my starting point to find out all this information. And the 7 here just happened to be the first one that I found, which actually worked out for me, because after finding the 7, I found that measurement there, and I've marked it with a 5 there because there's a reason for that, and that was from that corner there. I marked a line there, and that gave me that point there. And from there, I connected a line from that point to that corner, and I found that gave me one side of a pentagon. Yeah, you can see that line there. So it's just, I've been tinkering around in here and just looking for stuff, finding stuff, and then finally I found something. And there's lots of ways to kind of find stuff in the area of geometry. And just by starting with that symbol, I wanted to see what it might possibly lead to. So that's just what I found. And so after finding the 7, I found the 5. And after finding the 5, I took that measurement there and transferred that information to this point and made a mark there. And then when I connected that line to that corner, I found that it gave me the angle for a nonagon, which is 40 degrees. And so the only other tool that I used to check some of this information was I did use a protractor after the fact, finding this stuff, just to see how close I was. Let me see, how can I get this? And there you can see. It's almost dead center in the 40. The 60's on the 60. And that line was approximately passing through that 51 point something there. Although I did not extend that line all the way, I erased that section. So just to give you an indication, and of course this thing has its limitations of accuracy as well, right? This is not going to be to the equivalent of a digital precision instrument, but it's good enough for me to at least verify something, to get to the level of accuracy that I need for these kinds of projects. So that gave me that measurement there. And then I simply used that. Whoops, what have I done here? Did I get that right? No, I didn't. It's approximately there. And that gave me that. Whoops, what's going on there? So that was this whole exercise here. I was trying to actually use this symbol itself, and that was only a couple of days of exploring here with the symbol and seeing what I could find. Maybe there's more information. I don't know as of yet. But this is a good start, because as I was saying before, if you can get a triangle, you can get a 6, and a 4 is pretty basic geometry. And if you can get a 4, you can get an 8, right? If you can get a 3, you can get a 6. So these are the other ones here. I found the 5, 7, and the 9. And I just left this one here just as it is. What's the point? And everybody knows the other stuff already. Like I was just saying, if you can find a a 3, you can find a 6. If you can find a 4, you can find an 8. And so there is the 5, 7, 9. And if you can find a 5, you can find a 10-sided. If you can find a 7, you can find a 14-sided. If you can find a 9, you can find an 18-sided, right? And so if you can find your from 3 to 9, that's really good. If you're looking for like an exact, I don't know, 30-sided, kind of a thing or something like that. Yeah, I mean that's just something entirely different, and you're probably better off just using the convenience of precision tools and or modern technology with some software on your computer. But just to find this stuff at more kind of an essential level, something just slightly a bit beyond an introductory level, I think this stuff is really, really interesting. Yeah, so I think I covered everything I wanted to say there. Yeah, it was just it's interesting here, the symbol, because it does kind of leave you with a very nice blueprint and a template for working and finding this stuff, because you already have these your quadrants, right? And because you obviously need the circle as well, because then you can get from there to there, from there to there, from there to the edge of that circle there, and so you need the circle as well, which is what this old symbol has. It's got the triangle, square, and circle. And of course, in here I have included the horizontal axes and the vertical axes, which you need. And so I think that's it for this one. I hope actually the video quality is a bit better here today, because I have found a way to get a bit more light here. As you can see, the lighting issue is better here a little bit today, but we're still stuck with what I have to work with here. So this is as good as it's going to get, and that's it.